Strobel's research ultimately led him to conclude that materialistic explanations for the origin of life were deeply flawed. And his examination of negative evidence did not end with the question of first life. He also learned of weaknesses in the most celebrated icon of Darwinian evolution.
In Darwin's book on the origin of species, there's only one illustration. It's called the Tree of Life. Darwin used it to explain how every species of animal and plant that ever existed on Earth had evolved from the same common ancestor through small, gradual steps over enormous periods of time. Even though Darwin's Tree of Life is included in virtually every biology textbook published over the last half-century, contrary to what we've been told, there is no conclusive evidence of the common origin of all life.
Perhaps the most damaging blow to Darwin's theory is the fossil record. If all living organisms have descended from the same primitive life form, then the rock strata of the Earth should be filled with the fossilized remains of animals that were once part of a great evolutionary chain. A chain of small biological modifications, ultimately leading to a spectacular diversity of life. Yet, after 2 centuries of research, highlighted by excavations in southern China, the multitude of transitional experiments, or missing links, that should exist are conspicuous only by their absence. The most graphic example of this void in the fossil record is a geological era known as the Cambrian Explosion.
The branching tree pattern of Darwin's theory is actually not seen anywhere in the fossil record unless we impose it with our own minds. So the Cambrian Explosion is the most dramatic refutation of the Tree of Life.
The Cambrian Explosion of life was a dramatic episode in geological history. Usually dated at about 530 million years ago, the exquisitely preserved Cambrian fossils reveal that the body plans for virtually every major animal phyla appeared, not gradually and slowly as Darwin had speculated, but instead with astonishing suddenness.
If we imagine the whole history of life on Earth taking place in one 24-hour period, the current standard estimates for the origin of life put it at about 3.8 billion years ago, let's say 4 billion. So if we start the clock then, our 24-hour clock, 6 hours, nothing but these simple single-celled organisms appear, the same sort that we saw in the beginning. 12 hours, same thing. 18 hours, same thing. 3/4 of the day has passed, and all we have are these simple single-celled organisms. Then at about the 21st hour, in the space of about 2 minutes, boom, most of the major animal forms appear in the form that they currently have in the present. And many of them persist to the present, and we have them with us today. Less than 2 minutes out of a 24-hour period. That's how sudden the Cambrian Explosion was.
In a geological instant, the animal kingdom leaped from small, relatively simple organisms to extraordinary creatures with spinal cords, compound eyes, and articulated limbs. The record of this explosion of life looks nothing like Darwin's slowly branching tree.
Darwin's theory is that there's a tree of life, where you have one organism diverging into many other organisms and big differences appearing at the top. What we really see is from here up. This does not exist in the fossil record. If I were using a botanical illustration, it would be a lawn with separate blades of grass sprouting independently of each other. And those would be the phyla. Now within each phylum, there is subsequent diversification. But even there, I don't see the branches connecting that would make them a tree of life. As scientists, it's not our job to force the evidence into a theory that just doesn't fit it. And so I have absolutely no desire or reason to uphold Darwin's theory at this point.
Well, one of the most intractable problems in paleontology is one of Darwin's own devising. When Darwin wrote The Origin of Species, he knew of a group of fossils low in the geological column called the Cambrian. Since Darwin believed that all animals shared common ancestors, he believed that the animals in the Cambrian must therefore have ancestors in the rocks below them. To put the Cambrian explosion in context, let's think of Earth history like a football field. On an old age system, the beginning of the Earth at one end zone is 4.5 billion years ago, and the present is at the other end zone. The Cambrian starts all the way across the field at the opposing team's 12-yard line and extends for 1 full yard. The Cambrian explosion, though, where we see the first appearance of all of these different animal body plans, these phylum-level divisions, happens in just 4 inches. It's not even the whole yard. So in the 4 inches that is the Cambrian explosion, this narrow slice of time in geology, we have the first appearance of animals that are as different from each other as mollusks and clamshells from jellyfish. These are huge anatomical differences that are supposed to happen in a window of time where in other areas you're arguing about whether or not humans and gorillas shared a common ancestor. A small difference anatomically compared to the huge body-level divisions that we see first appear in the Cambrian.
Marcus Stewart and I were talking about the complexity, the design of the creatures. Do you as a paleontologist see that in that fossil record as well?
Absolutely. We see complexity at 2 levels. One level is in the integration of the ecosystem, right? That the first time you find these communities destroyed, that the ecosystem itself is complex. But you start digging down and the complexity levels actually increase, they don't decrease. So in the Cambrian, with the first layers of rock that have lots of fossils in them, called the Cambrian Explosion, you have things like trilobites that show up for the first time, looking from the bottom up. It has an eye like a dragonfly. And there's dozens of little lenses in it that allowed them to see all over the place, behind them, in front of them, on the sides. These eyes, in some of these trilobites, are the most complex eyes in the entire world. These are levels of complexity that far exceed any of our engineering capabilities. We can make drones and we can put a camera on a drone, but none of the cameras that we have built are anywhere near as complicated as some of the first eyes that we see in the lowermost ecosystems. It tells us that when these ecosystems were destroyed, they were fully complex structures with fully complex organisms with fully complex components. The complexity just keeps going all the way down.